All right, just making sure that audio works. It looks like it is working. Perfect. Welcome. This is our 9.8 and 9.9 sections of Unit 9. This is our last couple sections, and then we'll be rid of circles for the time being. We'll see a couple more in our next unit, Unit 10, actually, with cylinders, and I think we're going to talk about cones, maybe. I'm not too certain. I'll have to look back at the notes and whatnot. But what we do know for sure is we're going to finish up 9.8, 9.9. Okay. And so in order for us to start, we have to first establish, right, circumference and be able to identify what circumference is and whatnot. And circumference is actually really easy. Okay. Circumference is essentially just the entire outside of the circle. So what that means is we're going to take a piece, oops, second. Okay, what circumference does is that it's entirely the outside of the circle, or I guess you could say the circle itself. Right. So if we start at this point right here, what is the distance that we travel all the way back around? Okay. That's what we're measuring. So whenever we're looking at circumference, there's actually two kinds of equations. We can use C equals pi times D, or we can use C equals 2 pi r, where D is the diameter and R is the radius. I'm not sure why it's going forward. R is the radius. You know, all that stuff like that. Okay. So now what we'll do, we'll take this approach for a circumference of a circle with a radius of 9 centimeters. What that is that we're going to say, well, radius, right? We already know our radius is going to use this equation. So C equals 2 pi times our radius, which is 9. And then we'll just keep going. C equals 2 times, well, I don't even say 2 times 9, because we already know what 2 times 9 is. It's going to be 18 times pi. And depending on the situation, if it says to leave in terms of pi, 18 pi is a perfectly good answer. But if we're looking for a decimal answer, you're going to say, well, put 18 times pi into your calculator, round to the nearest third decimal, get 56.54 centimeters. Okay, make sure you put that centimeters in there. This is a measured unit. Well, we can go one way, we can go the opposite way. So instead of for B, we're going to start with a circumference of 26 centimeters, or sorry, 26 meters. And that is going to be equal to 2 pi r. R is what we're looking for, radius of the circle. And then you're going to just take 2 and pi and move it to the other side. Realize that pi is just a number, right? It's just a number. Nothing, I shouldn't say nothing special about it because it is a special kind of number, but nothing unknown about it, I guess you could say. It is represented as 3.14, but then obviously there's like a ton more decimals after that. But we'll take that, 26 divided by 2 pi equal r. You put this into your calculator, r is going to approximate to 4.138, and make sure you use the correct units, meters, like so. Moving forward, right, we have key point 1 here. In key point 1, the first couple of lengths here is an arc, arc ARC, not like Noah's arc ARK, and they're different. An arc length is a portion of the circumference of a circle. You can use the measure of the arc in degrees to find its length and linear units. Linear units just means like your inches and your centimeters and your meters and all that stuff. Okay, basically, if this circle was unraveled and turned into a straight line, what would it look like? Okay. Then we have our arc length core concept. Okay, these two things right here, are really just one of these, top one, I should say. Top one is on your formula sheet. This is on your formula sheet. So no need to memorize this, which is really good for us. And something that I want to kind of cover before we move on with that idea is that for arc measures, like so the measure of an arc, that's in degrees. Okay, beforehand, we always said the arc measure, the measure of arc AC, for example, is 57 degrees, right? We'd always say degrees. But the arc length actually has, well, a length to it. So arc length is measured in inches and centimeters and meters, etc. Okay, anything else that can be explained like that. But we're going to take these two ideas, right? We have our degrees, we have our measure, right? Our arc lengths and whatnot. We're going to take those and push them together. So what we'll do here is we create this formula. Well, the formula helps us to understand a couple things, or rather, a way to help us understand the formula a little bit better is this way. You're going to take part of the circumference. Okay? That is the arc length part of the circumference over the whole circumference. That is the entire left-hand side of that equation. Equal to an arc measure over the whole arc. Which the whole arc is, of course, the whole circle, 360 degrees. Okay, so that's where we get all of those little pieces from. Now, for the most part, it should be relatively simple as long as you're putting the pieces together in the correct way. Okay, so using our intuitive nature, we're gonna go ahead and look at some problems. And here we have 3 problems. Okay. And these 3 problems all ask for different things. So if I were to rewrite my equation up here, so I have arc length. And of course, you don't really have to do this because you have the side by side with you. You have your arc length with 2 pi r equal to your arc measure over your 360 degrees. And so in A, we're looking for our arc length. And so what we'll do for this one to adjust our equation, we're going to solve for arc length. We're going to have to say that x equals something. And in this case, x, our variable, is going to equal our arc length. We'll say x over 2 pi r equals, or actually, abbreviate a little bit of this. We know we need to find our arc length. We know our radius here is r, and 8, or sorry, our radius here is 8, and then 8 times 2 is 16. We put 16r. Okay, realize all I'm doing is multiplying my radius 8 times 2 to equal 16, and I'm replacing it down here. Then we'll do the same over here. We put the 60, that's our arc measure, over our 360. Okay, we know that 60 is our arc measure because this is the central angle. And angle P, and here is the central angle. Therefore, the arc measure is the same. Then for B, circumference. Okay, circumference. Now I have everything else. So I have the arc measure, which is right here. Actually, I'm going to take a different hint to this, just so we can see the different problems. I have my arc length. I have 4.19 over my unknown, which is my x, equal to my arc measure over 360. Okay. And then the last one Last one here, we know it's going to be our arc measure that we're looking for, because we have our radius. We have 2 times pi times r, our radius, 15.28. And whenever we put that as our radius, we get 30.56 r. Sorry, 30.56 times pi. Our arc measure, or arc length rather, is 44. We're looking for our arc measure, which is x. And we know that the whole arc measure is 360 degrees. Okay. So looking at these problems, you'll solve for x. It's actually much easier than we may think. Okay, so don't make it much harder on yourself. I would just leave it exactly how it is. Okay. When you do this, you're then going to cross multiply. You get 360 times x equals 60 times 16 pi. Okay, don't make this harder on yourself. Then instead of multiplying out 60 times 16 times pi and all that stuff, just divide by 360 on both sides. You may think at first that this doesn't make any sense or making things difficult on ourselves, but luckily for us, we have calculators. So as long as I have 60 times 16 times pi for 360 degrees, which really isn't degrees anymore at this point, then I can just plug this into my calculator. Don't make things harder on yourselves. Don't have any chance to mess it up. Okay, so when you redo this, you get x equals 8.378 centimeters. That's it. You're taking the exact same approach with the other problems. Cross multiplying. You get 360 times 4.19 equals 40x. Divide by 40. X is going to equal 360 times 4.19 over 40. X will equal 37.71 inches. Yeah, of course, the x refers back to the arc length in the previous problem and the circumference in part B. Last but not least, part C. This one should be even easier since our x is in the numerator. We can just multiply through. You could have also done that with the first problem, but I think showing the cross multiplication is effective. X equal 44 times 360 over 30.56 pi. We get an answer of 164.988. Okay. Realize here that I multiplied 360 times 44 because 360 is understood to be over 1. You multiply across with fractions, and that's why we have this. Okay. Now, for the next couple problems, go ahead and try them on your own first. And then you can go ahead and come back. Set up this problem. We're looking for arc length. So we need x over 2 pi 12 in this case is what I'm working with, is my radius, equals 100 over 360. Here, since I have my x in the numerator, I can just multiply across by the denominator. I'm going to subtract that on both sides. I'm not writing it up here because I don't have the space for it, but you're multiplying 2 pi times 12 on both sides. Via x equals, okay, remember again that because this idea, right, 2 pi and 12, those are all just numbers. It's understood to be over 1 as a fraction. So I'll multiply across 100 times 2 pi x 12 over 360. Okay, whenever you put this into your calculator, just put it in exactly how it shows. 100 parentheses 2 pi parentheses 12 parentheses over 360. Or what you can do is just multiply all the way across and then divide by 360. Okay, this is all just multiplication. Okay. So what we do from here for part B, we're looking for the circumference, which means our variable is going to be in the denominator, so we can't just multiply across easily. You know, the arc length is 6.5. We're looking for our circumference. We know the angle is 130, and we know that the whole arc is 360 degrees. Okay. Now, we'll do cross multiply. We get 130 x equals 6.5 times 360. Divide by 130 on both sides. X equals 6.5 times 360 over 130. Therefore, x is going to equal 18. Okay. Okay, I apologize for going so fast. However, I really need to get through these problems, and I only have not a lot of time. Actually, way less time than I think I do. Okay, by a lot. Okay, so we'll do this one quickly. We're looking for our arc 21 over 2 pi 14.32. That's our radius equals x over 360. Multiply 360 both sides. Get x equal 21 times 360 over 2 pi times 14.32. Board is being really slow today. X equals 84.023. Just like so. Okay. Then we have our next problem. Okay. Here, don't be distracted. Okay. We know that we have 128 degrees of arcs. We're going to take our radius of the arc for a runner on the red path. Okay. The red path is only 36.8 meters for the radius. So this 44 here is a distractor. Okay. And in actuality, we're looking at a couple different things. Okay. Here we have two semicircles and a rectangle. Okay. And we want to look for how far does the runner travel around the track, rounding to the nearest tenth of a meter. So in order for us to figure this out, we have to put them together. Okay. We want the distance. The distance is going to be the two straightaways. Plus the two semicircles. Like so. So we need to figure out their lengths. The semicircles is just how we normally would, right? We know the radius is 36.8. So we have x over 2 pi 36.8 equal to 180 degrees over 360. And I know it's 180 degrees because one, it tells me, and I know that these are semicircles. Multiply everything in the denominator of the x over. So 180 times 2 pi times 36.8 over 360. And then from there, you should get an answer of x equals 115.611 meters. And the straightaway is pretty easy, right? That should be pretty easy to see. You get distance equals to 2 times the straightaway, which is 84.39, plus the two semicircles, which is 115.611. And we get an answer of 400.002 meters. Okay, rounded to the nearest tenth of a meter would be 400 meters, because 0 can't round it. Okay, so this would approximate 100 meters. In this problem, it's kind of similar to the previous one, just a little bit different. Now we're looking for the nearest foot. Yep, there it goes. Okay, hold on. Sorry, y'all. And I think the share screen stopped too. Yep, I thought so. Technology, love it so much. Okay, looks like it's good now. So here we have to the nearest foot is what we're looking for, and how far does the tire travel when it makes 15 revolutions? Okay, this is a very, very particular thing. Okay, whenever something makes a revolution, it takes 1 point, let's say this is the point of the tire, and how much distance does it cover for every full revolution? It says rotation kind of works the same way. They're not quite exactly the same thing. We'll talk about that later probably. But basically, how does it get from 1 point to the exact same point, and how much distance does it travel? Okay, so what this one will do is we're going to take the distance equal the number of revolutions times the circumference. Okay, which should be pretty easy for us. We already know the number of revolutions we need is 15. And here we need to figure out the circumference. Well, it gives us the entire tire. It gives us into 3 increments. So for our diameter, it's going to be 5.5 plus E plus 5.5 equals 26. So remember in the very beginning, we said that we have 2 equations, pi times d, or 2 pi r. In this case, we're going to use pi times d. And so whenever we multiply this out, we get an answer of 5.220. But be careful here, right? The diameter is measured in inches. Well, we don't want inches. We want to the nearest foot. Well, how many inches are there in a foot? There are 12. So we got to divide our answer by 12. We get an answer of 102.102 feet. But right into the nearest foot, 102 feet. Okay. Rather simple. Now, for our notes here, the definition of the radian is the angle made when the radius is wrapped around the circle. Okay. And there's a couple key things that I need you to write here as well. Okay. In the notes little section here, you're gonna write another way to measure angle. Okay. Another way to measure angles. Then we say always written in terms of pi. Meaning that you leave the pi there, you don't multiply across with the actual number. Third thing, takes pi radians to make a semicircle. And the semicircle is 180 degrees. Then the last piece, radians can convert to degrees. We'll take radians to degrees. That will be 180 degrees divided by pi. But if you go one way, you can go the other way. So for degrees to radians, you're actually going to go the opposite ways. Pi over 180 degrees. Okay. The reason we do this is that it allows units to cancel. Okay. So if we go from radians to degrees, remember we go leaving the radian in the pi, right? But then we divide by pi. So that takes out the pi's. But if we go from degrees to radians, we have a degree measure, and then we're dividing by a degree measure, the degrees are going to cancel out. Okay, so that's how we're able to do all that stuff. The next couple examples are pretty easy. We're going to do some radians to degrees and degrees to radians. So if we're converting 45 degrees to radians, right, we're going from D to R. Well, D to R said multiply by pi over 180 degrees, right? Because we have our degrees here. Those are going to cancel each other out. We're left with 45 pi over 180, which that equals 1 over 4 pi. Okay. And that's our answer. You technically, I guess, technically it is correct to say pi over 4 radians. I can't think in any capacity of my college career I've ever really converted to just radians like that. But I know for sure in other locations or other math subjects and whatnot that you do radians like this. Okay? So make sure you're doing it correctly. Here we're going from R to D. So we have 3D pi over 2 times 180 over pi, 180 degrees. The pi's will cancel out. 3 times 180 is going to be, trying to do some quick math, for 540 over 2. That's 540 degrees over 2. And you divide it out, we get 270 degrees. Try the other two by yourself. All right. Here we're trying to go from degrees to radians, so just like the previous example, we'll do 160 degrees times pi over 180 degrees. Those are going to cancel out. Left with 160 pi over 80. And we'll simplify 8 over 9 pi radians. Here we have radians to degrees. 5 pi over 6. Try this. Very good. 5 pi over 6 times 180 degrees over pi here. Divide out the pi's, multiply across 0, 0, 900. Divide by 6. We get an answer of 150 degrees. Okay, that's all the time I have for right now to really cover this material. Okay, so really I was only able to get to 9.9, sorry, 9.8. So the next video will be 9.9. Just kind of bear with me while I try to figure that out. I was not expecting to be called for coverage. That's okay. Well, if there are no questions, we will go ahead and cut this video. And I hope you all study up and try to get all that work done. Okay. Alrighty. I'll see y'all later. Bye-bye.